third reassessment video, we're going to do multiplication algorithm. So the definition of multiplication is that you have a bunch of groups of the same size, and you add up or count the content of the groups. So to better understand this, we have a word problem. Hannah has 1,204 bins. Each bin has 2,379 pencils in them. How many pencils are there altogether? So to go back to the definition, you have a bunch of groups, which would be 1,204 of the same size, and you count the contents of each group, which would be 2,379. So we want to multiply these two numbers to get the grand total of how many pencils are in each bin. So in order to do this, we have to understand base 10. So I wrote out 2,379 in base 10 blocks, so that would be 2 supercubes, 3 flats, 7 rods, and 9 singles. So first, we're going to do this problem in sub-problems, or divide each problem in little mini problems. So for example, we have 9 times 4, 7 times 4, and multiply each number by this same number, because we're trying to add up or count the contents of the groups. And we do this by multiplying this number times this number, but in an easier and more efficient way, 9 times 4. So we are dividing each of these multiplications into smaller multiplication problems to make it easier and also better understand it. Because we are working with 4 different units this time. We have the singles here, the rods here, the flats here, and the supercubes here. So since we are in 4 different units, we have to divide it up and multiply by each unit at a time. We can't multiply all the units together. That's just not possible. We have to divide it up into sub-problems. So to begin, we have first 4 times 9. Alright, so we're working here 4 times 9, which would be 30, which would be 9 singles times 4 singles, okay? And that would give you 3 rods plus 6 singles. And you carry the 3 up here, because since we are in the singles place, we cannot put the 3 here. We have to put the rods in the rods place, so carry that up. Now we do 4 times 7, which is 28 rods, plus 3 rods, that 3 right here, which would give you 3 flats and 1 rod, and carry the 3 again once more. Alright, then we do 4 times 3, which is 12 flats, plus that 3 flats that we carried up here, to give you 1 supercube and 5 flats, and carry the 1 over. So carry that over. Alright, now we are going to do the final number, 4 times 2, and since, again, we are in different units, we have to do it in sub-problems, because you have a bunch of groups of the same size, and you add up or count the content of the groups. So we have to add up the content of each small group or small unit: singles, rods, flats, and supercubes. So now to continue, 4 times 2 is 8 supercubes, because we are in the supercubes place. And plus that 1 supercube that we carried over, to give you 9 supercubes. So we get our first level right here. Now we move over to the tens place, or the rods, because now you're multiplying by the rods. Remember, we were in the singles place. Now we are in the rods place. So we put that 0 here because we are working with rods, not singles anymore. Remember, we are dividing it up into different units. So now we're in the rods. So now we're multiplying everything by 0. It's a lot easier. 9 times 0, 0, 7 times 0, 0, 3 times 0, 0, 2 times 0, 0. So we get 0 for that level. Now we are moving on to another unit, another sub-problem, and we move over 2 places because we did the singles, we did the rods, now we are in the flats because we're dividing the problem up into sub-problems and working with flats now. So now we're multiplying everything by this 2, or this 2 flats right here. All right? So now we have 2 times 9 right here to give you 18 flats. Since we're in base 10, we cannot write 18 right here. We have to divide the problem up into 2 different units, 1 supercube and 8 flats. Now we have 2 times 7, which is 14 supercubes plus 1 supercube. And we carry that over up above here. And that would give you 15 supercubes plus 1 supercube plus 5 supercubes, and carry that 1. All right, now we have 2 times 3 right here. So we're still in the flats place since we moved over 2. To give you 6 super rods plus 1 super rod. To get 7 super rods, and we have to fit it in base 10. It does fit in base 10 since it's not over 10, so we don't have to carry anything up above here. We don't have to move it over to the next unit, the unit above. All right, and this is also easy. We have 2 times 2, which is 4. Since we're in base 10, we don't have to carry anything, so that fits right there. Now we're moving over again to the thousandths place, or the supercube, because now we're multiplying by supercubes. So since, again, as I mentioned, why we can divide this problem up is because we're working with 4 different units. Now we're in the unit of supercubes, all right, which is the 1 right here. All right, so now this is also easy, multiplying everything by 1. 1 times 9, 1 times 7, 1 times 3, 1 times 2. Right here, 1 times 9, 1 times 7, 1 times 3, 1 times 2. And that all gives you 9, 7, 3, 2. All right, so we multiplied all this. We have a bunch of groups, and you add or count the contents of the groups. So now we have this, all these numbers here, and we have to add them up vertically because it's really 1,204 groups of 2,379 things. So we are adding this up because you want to find the content of the groups. So we're adding up vertically, so 6 plus 0 plus 0 plus 0, 1 plus 0 plus 0 plus 0, and you add up all these vertically. And just like multiplying, we are dividing these up into sub-problems because we are working with different units. We have the singles, we have the rods, the flats, the supercube, super rod, and continue. So since we're in different units, we have to divide it up. And we can't just add up all these in one problem. We have to divide it up to make it easier for us. So since we multiplied in steps, as I said, we are adding in steps. So to get the final answer, you have 2,864,316 to get your final answer of the word problem. How many pencils are there all together? So we have the groups and the fixed number in each group to get your final answer. Thank you.